There are two more problems from section 04 that I've been asked about. They're story problems from that section, number 69 and 71. And anytime you're faced with a story problem, whether it's in calculus, whether it's in physics, if there's a picture you can draw, you definitely want to draw that picture. And if you look at the situation that's described here in problem 69, it says a person is sitting 2 miles from a rocket launch site, and they measure a 20-degree angle up to the current location of the rocket. How high up is the rocket? So if we have the person sitting over here, and I am by no means an artist, if the person's sitting here and they're on the ground and they're 2 miles from where the rocket was launched, the rocket is traveling upward this direction. And what they're saying is happening is that the person is able to measure that the angle from them up to where the rocket currently is 20 degrees. Now, 99% of the time in calculus, we're going to be measuring angles in radians. And the reason why is because radians are considered technically to be dimensionless while degrees are not. So a lot of the formulas we develop over the course of the year are only going to be allowed to be used in radians. So we have to be really careful with degrees. There's not really any calculus involved here. This is just some review stuff. All we want to know is we want to know how high up the rocket is. So we essentially want to know what this is. How many miles up off the ground is the rocket at this time when the person measures that angle? So what we can go ahead and do here is we can kind of boil it down to just a SOHCAHTOA problem. And we know that the leg of the triangle adjacent to the 20-degree angle is 2 miles. We don't know what the opposite angle, right, the angle on the other side of the triangle from that 20-degree angle is. We don't know what the opposite angle is. So if we're using SOHCAHTOA, the O and the A, the opposite and the adjacent leg, are part of the tangent function. And when you have a trigonometric ratio that you're setting up, you always want to put the angle measure that you're using inside that trig ratio. So we want the tangent of 20 degrees, and that's going to be equal to opposite x over adjacent 2. And if we go ahead and solve this for x right now, just multiply both sides by 2. 2 times tangent of 20 degrees is something we want to toss into the calculator, and then we want to use that to estimate our answer, the height of the rocket. One quick comment, I've seen people make this mistake before. It's tempting when you multiply both sides by 2 to try and multiply the 20 by 2 and turn it into a 40. You can't multiply this 20 by anything. It's inside of a set of parentheses, right? We can't distribute into trig ratios. We can't do that. So we're just going to multiply the tangent ratio by 2. So it's going to be 2 times tangent of 20 degrees. Now when you do take out the calculator, and you're going to have to be really careful of this, a lot of you are going to be taking calculus and physics concurrently this year. If you use the same calculator in both classes, what you're going to have to make sure you're doing is being very, very cognizant of what mode your calculator is measuring angles in. And so if you go to the mode screen, we in calculus 99% of the time want radians to be how we measure angles, but this one problem has the angle measured in degrees. So what I'm going to do real quick is I'm going to bounce my calculator into degree mode, and then if I just went ahead and do 2 times tangent of 20 degrees in the calculator, I get my value. So the rocket is approximately 0.72, I'm going to round this to 3 digits beyond the decimal, so 0.728 miles off the ground at the time when the person measures this 20-degree angle. We're going to look at similar setups later in the year, but the cool thing that we're going to be able to do once we know a little bit of calculus is we're not going to just be able to measure how high the rocket is or how far the person is from the rocket. We're going to be able to measure how quickly the rocket is rising, how quickly this angle that the rocket is, the angle of inclination right here, how quickly that's changing. So calculus is going to be the study of change. There's not really anything changing here. We want to know one value at a certain instant in time. And we're not necessarily concerned with speeds that things are changing here. Calculus is going to be concerned with those things. When you look at 71, you're going to have a similar question. You want to draw a diagram, label the diagram, and then use some SOHCAHTOA to answer the question that's ultimately asked.